ASML's machines, for instance, rely on unique components sourced from companies in Japan, Germany, and the United States. Replicating this ecosystem within China will take time and significant investment. ASML, headquartered in Veldhoven, Netherlands, has long been a symbol of Western dominance in high-tech innovation. The company's EUV lithography machines are not just marvels of engineering, but also the backbone of chip production for some of the biggest technology players, including TSMC, Intel, and Samsung. Each of these machines, which cost approximately $200 million, is a masterpiece of precision engineering, built with thousands of intricate components sourced from specialized suppliers. Around the world, ASML's supply chain, partnerships, and R&D efforts have positioned it as an indispensable player in the semiconductor industry. However, Huawei's announcement of its self-developed EUV lithography technology presents a paradigm shift. If Huawei can successfully commercialize its patented EUV machines, it would break a critical bottleneck in the global semiconductor supply chain. Currently, many chip manufacturers are reliant on ASML's technology to produce the most advanced chips, those smaller than 7 nanometers. Huawei's potential entry into this space could disrupt the status quo, offering an alternative supplier and reducing dependence on Western technology. What makes EUV lithography so revolutionary? To understand the significance of Huawei's patent, it's important to grasp why EUV lithography is so transformative. Traditional lithography methods use deep ultraviolet DUV light, which operates at wavelengths of around 193 nanometers, to ETCH circuit patterns onto silicon wafers. However, as the demand for smaller and more efficient chips has grown, DUV technology has approached its physical limits. EUV lithography, with its much shorter wavelength of 13.5 nanometers, allows for the creation of finer, more intricate patterns, enabling the production of chips with higher performance and lower power consumption. The process of generating EUV light is, however, extraordinarily complex. It involves firing high-energy lasers at tiny droplets of molten tin, causing the tin to vaporize and emit EUV light. This light is then collected and directed through a series of mirrors and lenses, ultimately projecting the desired pattern onto a silicon wafer. The precision required in this process is staggering, and the slightest contamination or misalignment can compromise the entire chip. ASML's machines have mastered this process. With years of research and billions of dollars in investments, the company has also benefited from collaborations with leading semiconductor firms, who have provided valuable feedback and funding to refine the technology. Huawei's ability to develop a competing EUV machine, therefore, underscores not just its engineering prowess, but also its determination to overcome significant barriers. The geopolitical context. Huawei's advancements in EUV lithography come at a time of intense geopolitical rivalry between China and the United States. In recent years, the U.S. has imposed stringent sanctions on Huawei, cutting off its access to advanced chips and semiconductor manufacturing tools. These measures, aimed at curbing China's technological rise, have spurred Beijing to invest heavily in achieving self-sufficiency in critical technologies. Huawei, as a national champion, has been at the forefront of these efforts. The Chinese government has poured billions of dollars into semiconductor R&D subsidies and talent development. Domestic companies like SMIC Semiconductor Manufacturing International Corporation have been working to catch up with global leaders like TSMC and Samsung. Huawei's progress in EUV lithography could be a game changer, enabling China to produce cutting-edge chips domestically and reducing its reliance on foreign suppliers. Moreover, Huawei's breakthrough sends a clear message to the world. China is not merely a consumer of technology but also an innovator. This shift has significant implications for the global semiconductor industry, as it introduces a new competitor with the backing of the world's second-largest economy. Challenges ahead for Huawei. While Huawei's patent announcement is impressive, translating it into a commercially viable product will be no small feat. EUV lithography machines are among the most complex devices ever created, requiring not just advanced engineering, but also a highly specialized supply chain. ASML's machines, for instance, rely on unique components sourced from companies in Japan, Germany, and the United States. Replicating this ecosystem within China will take time and significant investment. Additionally, Huawei must overcome technical challenges. EUV technology is notoriously difficult to perfect, with extremely tight tolerances for precision and cleanliness. Any deviation in a process can result in defects, making it essential to maintain an ultra-clean, vacuum-sealed environment throughout the lithography process. Huawei's ability to achieve this level of precision will determine whether its machines can compete with ASML's. There's also the question of market acceptance. Semiconductor manufacturers have relied on ASML's technology for years and may be hesitant to switch to a new supplier, especially one with no track record in EUV lithography. Huawei will need to demonstrate that its machines are not only competitive in terms of performance, but also reliable and cost-effective. ASML's recent seismo is not sitting idly by as Huawei makes its move. The company's ability to maintain its leadership will depend on its capacity to push the boundaries of what's possible in lithography technology. In conclusion, the battle between ASML and Huawei is not just about market share. It's a contest for technological supremacy with implications for global power dynamics. As the story unfolds, one thing is clear: the race for the future of chip manufacturing has never been more intense, and the stakes have never been higher. These partnerships provide ASML with a steady stream of revenue and valuable insights into industry needs, enabling the company to tailor its innovations to customer demands. The broader implication to Huawei's entry into the EUV lithography market could have far-reaching implications for the global semiconductor industry. By offering an alternative to ASML's machines, Huawei could increase competition, driving down costs and accelerating innovation. This could benefit chip manufacturers and consumers alike, as it would enable the production of more advanced chips at lower prices. At the same time, Huawei's progress raises concerns about the potential misuse of advanced technology. The US and its allies have long accused Huawei of posing a national security threat, alleging that its equipment could be used for espionage. The prospect of China achieving self-sufficiency in semiconductor manufacturing has heightened these fears, as it would reduce the West's leverage over Beijing. The road ahead semiconductor industry is at a critical juncture, with technology and geopolitics increasingly intertwined. Huawei's advancements in EUV lithography mark a significant milestone, but the journey ahead is fraught with challenges. To succeed, Huawei will need to prove its technology, build trust with customers, and navigate a complex geopolitical landscape. For ASML, the rise of Huawei serves as a wake-up call to stay vigilant and continue innovating. The company's ability to maintain its leadership will depend on its capacity to push the boundaries of what's possible in lithography technology. In conclusion, the battle between ASML and Huawei is not just about market share. It's a contest for technological supremacy with implications for global power dynamics. As the story unfolds, one thing is clear: the race for the future of chip manufacturing has never been more intense, and the stakes have never been higher.